Video 1 of our next chapter, we are going to be talking about everything circular. Circles, 2D. We'll also get into area and perimeter of circles. We'll get into volume and surface areas of cylinders, cones, and spheres. So first we're going to start off with really a lot of basic definitions in this first video about circles, and we will start with the most basic of definitions, a circle. By definition, a circle is defined as the set of all points equidistant or equal distance from a given point. So let's start with that last part of the definition, from a given point. Let's say here is our given point. And so now I need a set of all points. So I'm going to use this thing called a compass. And so with my compass, I'm going to put what I like to call the stabby end on that given point. And with my pencil over here, with this set width, I'm going to have a point, and I'm going to rotate this a little, and have another point, and rotate this a little, and have another point, and have another point, and have another point, and I start to wonder how many points could I, no, don't do that, how many points could I really create in such a way? And so theoretically, I could do this for the rest of my life, because for every 2 points that you make here, you could go somewhere in between those 2 points and make a point, and then between those points you can make a point, and in between those 2 points you can make a point, and eventually you might go, but you're going to run out of space there with your pencil. True in practice, but theoretically there's always going to be another point between 2 points. So all of these points that I'm making, and I'm not going to make infinitely many because, well, this video's got to end at some point, but you can start to see an outline of a circle here. And so when I say the set of all points, really when I look at all of those infinitely many points, then it creates a circle. So all of these points that are on this circle, they are equidistant from that given point. And so you might go, hey, I know a vocabulary word that describes that distance there. And just know that we can have infinitely of these many distances. Right? So again, I'm not going to keep going infinitely many times because, again, this video's got to end. So there's that particular term, radius. And so the radius is defined as the length between the center of a circle and a point on the circle. So you can kind of think of it as like basically halfway across the circle, but it's got to start at the center of the circle. And again, how many radii could I technically have in a circle? Infinitely many. And mathematically, we are going to refer to the radius as a little r. Next up, the diameter. The diameter is the distance across a circle, but it's got to go specifically through the center point. If I went just underneath the diameter and went across the circle from one point to another point, but I did not go through the center point, then that has a different vocabulary name. And this segment that I just drew in will be shorter than the actual diameter. So the diameter is actually the longest distance across the circle. And the diameter we will denote as a lowercase d for diameter. So little d for diameter, little r for radius. Then we're going to use this thing called a central angle a lot this chapter. And a central angle is defined as an angle whose vertex, remember the vertex is basically like the elbow of the angle, whose vertex is the center of the circle. So center of the circle, we go out, so here's a radius, and then here's a radius. So when you have 2 radii and they connect together at the center of the circle, that angle that is formed between the 2 radii is called the central angle. And there will be other types of angles that we'll eventually talk about, not this chapter, but later on, I think in the very last chapter, we'll talk about all sorts of other types of angles in circles. All right, 2 more vocabulary terms, lots of vocab to start off this chapter here. We've got minor arcs and major arcs. So arcs are going to represent they could represent one of 2 things. We could be talking about the distance of arcs, the length of arcs on the outside of circles, but we'll also talk about how many degrees that arcs could represent as part of a circle. And so to start off basically here, we'll say a minor arc makes up less than half of the circumference, or the perimeter of a circle. And a major arc is going to take up more than half of the circle. So notice here, this major arc, this green highlighted part here, that's more than half of the circle. And this minor arc, this kind of reddish arc, is less than half the circle. So then what would you call it if you had exactly half? Well, you wouldn't call it a minor arc, and you wouldn't call it a major arc, but what we'll call it is a semicircle. And semi is going to mean half here. So if we have half a circle, we have a semicircle. And so a semicircle is an arc that is exactly half of the circle. And again, we could talk about the length of what this is, but we could also talk about how many degrees a semicircle has. So again, semicircle exactly half, more than half major arc, less than half minor arc. So now let's talk about how do we name arcs. So first with minor arcs. Minor arcs, we need 2 points on the circle that are the endpoints of the arc. And then we're going to use a special arc symbol. Just like we had a symbol for lines and segments and rays, we're just going to use this curved little arc symbol above those 2 letters. So if I'm looking at this picture and I wanted a minor arc, an arc that's less than half the circle, well, I've got some options to pick from. Because I could say like arc AB, that's less than half the circle. And so how would I write that exactly? I would write A and B and then put a little arc over the AB. Now keep in mind that this could go backwards. Arc BA is the same exact arc. It's just named differently, flipping the letters around. I could also refer to arc BC. That's less than half of the circle. So again, I could name that. Let me grab the green here, maybe. Yep. We could go arc BC. And likewise, we could name some other arcs in here, like here's arc AD, here's arc DC. All 4 of those arcs are technically less than half of the circle. So there's just some examples for minor arcs. Major arcs, the big difference to know if we're really talking about a major arc versus a minor arc is major arcs are going to use more points to name it. And we need 3 points to name a major arc. 2 of those 3 points are going to be the endpoints of the arc, and the 3rd point is going to be in between the 2 endpoints. So for instance here, if I wanted to name an arc that was bigger than half the circle, let's say I start at A and I go to B and I'm not quite over half yet, and if I go from B to C, that's exactly half. I need more than half. So I'll just continue going on to point D. So if I went from A all the way around to D, A and D are the endpoints. And then I will still use an arc symbol here. But that middle letter just has to be any point that's in between A and D to get that major arc. So I could call this A BD, or technically I could call it A CD. And it would be referring to the same major arc. So even if I named it A, B, D, you might go, but what about point C? I didn't use it at all. I just ignore it. I can only use 3 letters. So if you go across 4 points, then you just skip one of the 2 middle letters, and it doesn't matter which one. Now, if I wanted to talk about, let's go around this way. If I had this big arc AB, then I would call it arc ADB or ACB. But I got to begin and end at the A and the B. So there's some examples for major arcs. And then we get to semicircles. Technically, semicircles need 3 points. And it's really going to work the same way as a major arc. We need to have the first and last letters be the endpoints of the arc. And really, that's going to end up being the diameter of the circle, right? Because the diameter is going to split the whole circle in half. So I know I got a diameter here. So here's A and here's C. And you might go, well, if I wanted to call this arc AC, then my question would be, which arc are you talking about? Because technically there's 2 arc ACs. There's this arc AC and there's this arc AC. And if I needed a specific arc, you would need to give me a little bit more information. So that's why we need that 3rd letter. So let me put a little bit of space between the A and the C. So if I wanted to talk about this arc AC, then my middle letter would have to be the B. And this would be arc ABC, semicircle ABC, right? But if I wanted to name the other arc instead, this arc that goes up across, then I would call this arc ADC with the arc symbol over it. So only minor arcs use 2 points. Major arcs and semicircles both use 3 points. All right, one more little tidbit of information here. The measure of an arc is congruent to the measure of its central angle. So remember, central angles have to be by the center of the circle. So what I mean by this is, let's come up with some numbers here. So this angle that's right here, let's just spitball and say that it's, I don't know, what do you say, 100 degrees, let's say. So if this central angle is 100 degrees, then what I'm also saying is that this minor arc is also a 100-degree arc. And if this central angle is 100 degrees, then that would mean the rest of this would have to be 260 degrees, right? Because there's 360 degrees altogether in a circle. And so if this central angle was 260 degrees, then that means this major arc is also 260 degrees. So arcs and their central angles are always going to end up being the same exact angle measures. And so arcs can be measured, and I mentioned this before, arcs can be measured in degrees, but arcs can also actually have length, curved length. And so how are you going to know the difference if I want a degree answer versus if I want a length answer? And that's all about this M that may or may not be in front of your arc symbol. Okay? So if I said, what is the measure of an arc, then anytime you see that M, then I'm asking for a degree answer. I'm looking for something between 0 and 360 degrees. But if I just say, what is arc AB, then that's implying that I'm looking for a length number. And we haven't gotten to that part yet. That'll be in a future video where we talk about circumference or perimeter, and then partial circumference or partial perimeter of circles. So just know that arcs technically could be expressed 2 different ways, in terms of degrees and also in terms of length. Just look out for that M and you'll know if it should be a degree answer or if it should be a length answer. And so to end out this video, we've got basically 2 examples. We're going to do one together, and then I'm going to have you guys practice your vocabulary with this example. So example 1 says calculate all missing central angles and arc measurements. So I give one central angle here. I give this 30-degree angle, and I give one arc measurement. Arc AB is 85 degrees. So just using those 2 things, we're going to be able to figure out how long arc, or not how long, but how many degrees arc BC is, how many degrees arc CD is, DF, and AF. And then we'll also figure out all these other central angles. So the first thing I would start with is if this is an 85-degree arc, then its central angle is also 85 degrees, right? Because we mentioned that a couple pieces back here. The measure of an arc is congruent to the measure of its central angle. Too far. And so we can bounce out from our 30-degree central angle. We can come out here, and so arc CD has a measure of 30 degrees. So you might go, okay, well that was easy, but what about the other 3 pieces of the pie chart here? Well, here's where we get some extra info. That AC and BF are technically diameters. So let's start with that first piece, that AC is a diameter. Well, a diameter is going to cut a circle exactly in half. And how many degrees does half a circle have? A circle has 360 degrees. So half a circle would be 180. So this angle right here, this central angle, would be 180 minus this 85 just adjacent to it. And so this would be a 95-degree central angle. And if that's a 95-degree central angle, then arc BC out here is a 95-degree arc. Now, if we go down here to this bottom piece, well, now we've got 1, 2, 3 angles that add up to be 180. And we only know one of those. So we kind of get stuck on some info here. So we don't necessarily want to do the same thing on the bottom like we did on the top. Now we're also told that BF is a diameter. So this also cuts the circle in half. So we could do the same thing over here and go, well, this central angle is 95 degrees, which also makes this arc AF 95 degrees. A type of angle that we've talked about in the past is that these angles are technically vertical angles to each other. And vertical angle, again, was when you had two lines cross paths. Vertical angles are opposite of each other. And we talked about, kind of informally, that vertical angles are congruent to each other. So we could have just used that fact, the vertical angles. Now, we could still, let's use some more vertical angles here. This 85-degree angle is vertical to really both of these angles here. And so if this angle's 30 degrees, then how much more would this central angle have to be to get a full 85? And it would have to be 55 degrees. So if that's a 55-degree central angle, this will be a 55-degree arc. And now we've got all of our arcs. And again, if I add up 85, 95, 30, 55, and 95, I'll get 360 degrees going around the outside of the circle. And if I add up 85, 95, 30, 55, and 95, I get 360 degrees going around the center of the circle. So whatever you see going on in the middle, around the center, should match up with what's going on out here on the outside. All right, the last example. This is your you-do problem. Based on all the information that we calculated in the previous problem, I want you to name 5 things. I want you to name an obtuse central angle. I want you to name an acute minor arc. I want you to name an obtuse minor arc. And I want you to name a major arc in general, doesn't matter how big it is, but a major arc. And I want you to name appropriately a semicircle. And so that is all for video 1.